Here's the derivative. F prime is negative 8 over x minus 5 squared. So what do I want? I want to know where f prime equals 0 or f prime does not exist. F prime equals 0 where the numerator is 0. F prime does not exist is where the denominator can't be 0. Well, is negative 8 ever equal to 0? No. So there are no critical values. No critical numbers coming out of f prime equals 0. Where does this thing not exist? Well, it doesn't exist at 5. What do we know 5 is? Vertical asymptote. So it is a VA, but it is of multiplicity what? 2. So that means there's no change. This guy he lives and dies by his VA. So here we go. Draw our number line. We have to put the VA on. I always put it on as an open dot because it's not included and it's not an x-intercept at all. So this is a VA, so I mark it as such. So I know that it's not a max or a min. So I pull a number, 0, that's my favorite. And I go back to this guy up here, and if x equals 0, am I dealing with a positive or a negative number? Negative. Because this is negative 8 divided by 0 minus 5 squared, which is negative 8 over positive 25, so this is negative. And there is no change across this guy, so negative followed by negative. This says he is always decreasing, right? Decreasing followed by decreasing. So he is always decreasing.
How would you write that?
You'd have to do minus infinity to 5 because 5's not in the domain. Five's a VA, he's not in the domain. That's why I put an open dot there. In particular because he is a VA. Because he's neither increasing nor decreasing at the VA. But that's a good question, one I hadn't thought of. I thought of all kinds of interesting things, but that's not one of them. So now we've got the fact that he's always decreasing. And if I go back to my original problem, notice he is always decreasing, the graph we drew using algebra. And now we take the second derivative. We want to know where f double prime equals 0 or f double prime does not exist. Well, that's where the numerator equals 0, is f double prime equals 0, or the denominator can't be 0. Is 16 ever 0? No. So there are no critical numbers. And here x can't be 5, but we know he is a VA. That's why we find the VAs to start with, because we know, because if I had more than one does not exist that I entered into, and we'll see a next problem is one of those. Not one of those exactly, but where you basically introduce something that does not exist. I know that is a VA, and so VAs act a little differently. And so at which point he is multiplicity what? 3. So that means that there is a change across there. That's a heck of a way to write change, but there it is. So here we go. The only thing I've got on here is 5, and that's my VA. So I pull critical number 0, my favorite. And if I put 0 in, positive or negative? Negative, yeah. 16 over 0 minus 5 cubed is positive in the numerator, negative in the denominator. This thing is negative. So negative change positive. So what this tells me is that this is concave down from negative infinity to 5, and then concave up from 5 to infinity. And then that should match my graph, concave down followed by concave up, yes?